Hello, everyone, and welcome to SBE Live. So excited for y'all to be here for this SBE Tech Talk. We are joined today with precision drilling, and today's discussion will be about creating a more advantageous automation process in drilling operations. I'm your host, David Gibson, and I'm so excited to be here with you. Anytime we're talking about drilling stuff, I am definitely psyched up to be able to do the interviews. So anyways, we've got an amazing expert being able to come on the show today. So be sure, throw out your questions, right? We want this to be interactive. We want to see where you guys are watching from. So let us know now. Where are you watching from? We'll give you guys a shout out here on the show. I'm guessing we'll have a very international audience, as we always do. Let us know if you've ever seen one of the SBE Tech Talks before in the past. And if so, which one was your favorite or how many have you watched, right? And as we go through today's show, be sure to throw out your questions, throw out your comments, anything that y'all have to say. We want this to be as interactive as possible. All right. Joining me today is Ashley Fernandez, Vice President of Drilling Technology for Precision Drilling. Ashley has worked nearly 40 years in the oil and gas industry, including experience with offshore rig operations, directional drilling, and now digitalization. Welcome to this SB Tech Talk. Thank you so much for joining us, Ashley.
Thank you.
All right, well, let's jump right into it. We are here to discuss transforming rigs from manual to automated. And that implies there are problems with manual. What main obstacles are disrupting the manual process?
So, David, look, I think I'm going to start with where we are today in unprecedented times, given geopolitics that's happening in the world today. And I think manual rigs, there was nothing wrong with them. It was very people dependent. Automation is still people dependent, but what we get with automation is consistency through using processes that are vetted, connected, and then input into the automation system. So just to touch on that a little bit more, what we do in this automation space today is we actually have the operators, drilling engineers, and our drilling engineers work collaboratively together to actually prepare a roadmap for their drilling plans. We then bring these roadmaps over to our automation systems. The automation systems ingest them and they coerce the drilling machines, if you like, to follow a charted course by the operator. Now, these courses can be changed at any time. We can actually input these and maneuver them as we drill along a well path. But the advantage you get out of doing this is everybody's singing off the same hymn sheet. Everybody within the rig, our crews, the operators, engineers, and the operators, people at the rig site are on the same page when it comes to drilling the well. What we also get out of this is, maneuvering processes. So added to these processes, and I'll talk about this with the screen you're seeing up there with the circle. So the digital well plans that you've got up there are what is the foundation of automation. Everything that the operator and precision and the third-party service providers like directional drilling, managed pressure drilling, etc., do go into this process digital well plan. These processes this digital well plan then feeds the processes like drilling, tripping, MPD, directional drilling, casing running, and power generation. So we have a measured process in place that the digital well plans are talking to. Now, think of the analogy. You can turn your car into cruise control and drive down a road every day, but the road conditions change when it's snowy, icy, or there's roadworks. So to maneuver these disturbances while you're drilling or driving, you need to have other applications that take care of this. And so it goes out to the next ring that you see that has a bunch of these applications that we call apps that then talk and refine these processes that are actually working in collaboration with each other. They talk to each other. These sub-processes, if you call them, or apps that you call them, are well-defined algorithms that are fitted seamlessly into the process that then talk to the machines like the top drive, the drawworks, the mud pumps, the generator. So let me give you an example, not to give you a long-winded answer, David, here, but an example.
No, go for it. This is great.
The example would be, you can take a really good driller, and we have a lot of those within Precision, and have these drillers tag bottom after a connection where you put the bit back to bottom. There's anywhere between 80 seconds to 240 seconds that a driller would take to put this bit to bottom. It's inconsistent. Some do it faster, some do it slower, some do it at a normal speed on every connection. But the big question is, what is actually good for the bit that's actually interacting with rock? Is it how fast the driller runs it, or is it what it is about the rock strength that the bit is engaging? And so what the digital well plan does is it takes into consideration rock strength, decides how fast we want to touch the bit to bottom or bit to rock, put that into the digital well plan, and the machine automatically takes over and runs that to bottom. So just that one process of tag bottom gives you additional bit life, gives you additional BHA life if you have motors downhole or RSSs downhole. And with that, we have several other processes and sub-processes that manage how we interact to drill efficiently, consistently, each time we make a connection or drill hole.
Excellent. Okay, so let me take a step back and be able to see, as far as transforming the rig from a manual to the automated, what does that first step look like?
So what we do today is, and we've got almost 50% of our rigs today kitted with these automated systems. So think about this as you have a car. Your car has cruise control. Now what we do is we go and add an additional computer that talks to these machines. So what we've done is we've added an additional process control computer to talk to our existing computer. And that computer then ingests all the processes and talks to the mainframe computer that handles the equipment. And what it needs and what is of prime importance in all of this is automation and process automation requires everything to work in orchestration or synchrony. It has to be down to the millisecond of each machine talking to each other, else the process breaks down. So for example, when the driller presses the button to start a mud pump in the normal world, he will bring it up at a certain speed. But if the process says, we can't bring the mud pump up at this speed, I'm going to break the process here and let the driller take over manually because he's bringing it up too fast. That cannot happen. What happens with the automation system is now the mud pumps, the drawworks, the top drive, everything works in synchrony. So, and everything works within the millisecond. You have to have these machines talking to each other with less than 30 milliseconds of latency in it. In other words, it has to be located on the rig floor within the frame of what the SBC is, or the single base computers on the rig floor talking to each other. So automation is not that simple. Having these computers and process automation computers installed at the rig floor require intensive amounts of time taken by people behind the scenes to make sure that the processes are working in synchrony, and hence give you the 99.8% automation that we have today. And I'm very proud to say that Precision took on this task of saying automation, it's not worth having automation at 40%, 50%, 60%. You press a button and the machine does what it's supposed to do 99.8% of the time. The other 2% of the time is us putting in, 0.2% of the time is us putting in all of these sub-processes, if you like, to alter or charter these courses. So to answer your question, David, what does it take to get away from the human to the machine? It's an addition of the computer, but the human doesn't go away. We rely super heavily on our drillers, on our remote ops in the back office, and on our optimization engineers to take care of this synchrony, if you like, and to make sure that we're consistent and performing at the same time.
We say performing at the same time, so that leads us into the next question, performance. If you talk to anybody in the hierarchy of the operation and around the word performance comes up, for something this important, how is performance affected by the digital well plans and roadmaps?
So digital well plans and roadmaps are the key, if you like, to everything consistency or everything performance. Now, you put in a poor digital well plan. It's the analogy of a CNC machine. You put your design into the CNC machine X, Y, Z, and if you have a poor vector axis cut, you're not going to get a good design. It's exactly the same here. The amount of time it takes for us to go look at these digital well plans and make sure that foot for foot or meter for meter in depth, we are putting the correct parameters to drill or cut rock to keep the BHA safe, to keep the bits with a longer life become of prime importance. And that's what performance is all about. We don't want to drill fast and trip too many times. We want to make sure that we can drill fast, keep the BHA in the hole, make sure we get to the goals of total depth, and then pull out of the hole, right? So the digital well plan or the roadmap is of prime importance. We need to make sure that we understand immaculately well, based on the customer's offset data, what parameters he used to drill his offset wells, what were the challenges he had, the number of BHAs he used to drill that well, and the number of bit runs he had to drill that well. And we pull all of that data in. We let our machines analyze that, and then our engineers, along with the operators' engineers, put all of this together in a form that actually forms this digital well plan. When we start drilling, and to keep performance at that level, we rely very heavily on our drillers and on the remote ops center that we have in town. It's very easy to say, oh, you're automated, take your people off. It's absolutely not the case with us. Our automation system requires our drillers to watch, make sure that conditions are not changing, and if they are changing, to make sure we react to the digital well plan in time through the assistance of the remote ops center. All of this is a process in the background that is well derived and drawn today, and that makes performance stay high and our wells drilled consistently. And the thing I'd leave you with here is, very often you'll say, oh, this driller drills or trips so fast or makes connections equally fast as the machine. Great. You can make connections really fast, but count the number of bit trips that you have, count the number of motor failures that you have. This is where you putting in the right parameters of consistency comes into play. And this is where our people and our remote ops centers and our optimization engineers help keep performance at the highest levels.
I imagine keeping that performance at a high level also means that there's going to be a lot of data involved. How much data are we going to be talking about?
Correct. And so it's very easy for me to sit here and tell you, oh, the driller does this and the ARO does this. None of this is done blindly. We ingest today around 70 billion tags of data. That's a lot of data that flows in. Think about this. We have around 120 rigs average working today. 70 billion tags of this come in to our servers, get processed, get analyzed, get pushed back out into the systems we need. And people in this industry would say, where the hell is he getting 70 billion bits of data from? EDR is not our data source. EDR is 1 second, relatively slow, run-of-the-mill. EDR has been around for a very long time. It's a digital recorder. If you want to see how fast a bit is tagging bottom and how fast you're running half a meter or a meter from your slips to the bottom of the hole, and you want to see where the bit engages rock, you need to have high definition data. That high definition data I'm talking about is at 8 hertz, 5 to 8 hertz, which is you're getting 8 shots in a second in high definition or in high density. We pull these 70 billion tags of data in, we send them through a process. We have these architectures for data made up where we can actually manage each of these processes on what we're looking at these processes. Our remote ops center leverages on them. Our teams at the rig site are the end users. So we don't expect our drillers to play with data. They become the end users who take the result of this data and act accordingly to this data. So data is a big part of how we maintain and keep performance and feed the insights to the drillers, to the AROs, to the optimization engineers that are looking at these rigs in the background, right? Without data, we wouldn't have closed loop adjustments. We would simply have to historically take that data in, digest it, feed it, look at the next well. It's for me, it doesn't make sense looking at data historically and making decisions based only on historic data. It's what's happening now to what you can do going forward as you drill down a well path.
What about the type of data? What are people normally looking at when the automation systems are operational?
So good, really good question. So the typical data set that everybody looks at is, your weight on bit, your RPMs, your rotations per minute, your torque, your flow, your differential pressure, etc. What our machines look at are completely different. What our machines look at is each step of the process that we build. So take, for example, when we make a connection, we come off bottom. So the machine picks the bit off bottom. We record how fast it's picking it off bottom. The machine then slows the pump down. We record how fast it's slowing the pump down and what rate it's slowing the pump down at. It brings it up to slip height and it stops. We record what distance it stopped at and when the slips went in. Again, when we make the connection and start up and when we pull out of the slips and run to bottom, we record how fast the bit's going down to bottom, when the bit tagged bottom, what the differential pressure took to go from its normal state to its drilling state. And then we look at what happens with the weight on bit when it goes from its off bottom or off rock state to its drilling state. All of this data is recorded, and you can say in today's world, oh yeah, we can get this data off EDR, but what you're going to get from EDR is 1 second data that you will not catch some of these instances, if you like, in real time. You will catch it. You can use this data historically to do some analysis, but not all. And so the data from our machines, be it the top drive, be it the drawworks, be it the mud pumps, be it the iron roughneck, be it the automatic slips, you can actually, time for time, actually measure these in high definition. In other words, what EDR gets in 1 second, I get in 5 shots per second, or I get 5 data points in a second. And that's what's important for us, right?
Well, I'm definitely a big believer in high frequency data. So you definitely got me sold there. And before we move on to the next question, we'll let everybody know that is watching. Be sure to get your questions in. If you've got some questions here for Ashley, we will go ahead and get those up there and get them fired off to him in here in just a second. So I want to be able to hear a little bit more from your experiences. What kind of success have you seen with drilling automation?
So huge successes. So, we've got some case studies up on our Precision website. And, I think while it does justice to what we do, it's far more than just those case studies we've got up there. We have a substantial amount of experience. We started this journey with automation here in Precision 2017, 2018. We decided to install these systems. And it was a really good corporate decision that we took, because if you look at where today's world is, it's going to, the business is going to grow. In other words, your rig count's going to start growing given where we are today. Are we going to get all these people back who have left the industry? You need automation to substitute some of this. And so we have today 51% of our fleet, or 50% of our fleet with automation. We've drilled over 2,300 wells today and counting. We've got rigs today that are flying with these automation systems. We've drilled over 35 million feet. But out of all of this, what's important is, and when I look at us in the rig contract space, we have 30,000 days of automation. And I measure days of automation where if it's up and above 99.5%, I count an automation day. 30,000 days is around 82 years of experience. Look, very easy to say, oh yeah, let's put an automation system. It's how you run it, how much experience do you have running it? And that's what makes us, good at what we do. And I can also tell you something, David. We are lending our lessons and our automation lessons that we learned to some of the offshore providers today, who are also using similar systems to us. So we are advanced and running in this field. Our experience in this field is second to none. I have yet to see somebody come tell me, hey, this is what we discovered with the automation system. Do you agree with me? And then the other thing that is good about this automation system and why it makes it special for us is it's an open SDK platform. David, if you have computer skills in automation, if you have a little company that wants to go from automation to control equipment, come talk to me. Bring it in. We'll put these apps on there. We can control processes. If you write the processes in code, we vet it through the platform owners, and we make sure that those apps or sub-processes work to run these machines. So it's not something that is locked, coded. It's only for Precision to manage. We could do this with anybody. we could have anybody building processes to run our machines, provided they were vetted through a proper process, right? You know, the last thing I want to leave you with on this topic of experience, it's not easy to run automation without the experience of the drillers. Our drillers, and if you think about it, if it's 50% of our fleet now having automation systems, take 2 of these drillers on a shift, rotating off a rig, we have a really nice bench of people who actually know how to run automation systems. And that is the difficult part in the industry today is, yeah, you can go automate something, but how do you get these people to actually manage the automation system, and how well trained are they, and what kind of experiences do they have, right?
Wow. I mean, lot to unfold there.
Absolutely.
Let me get you one last question, and then we'll do some follow-ups there. We've definitely got a couple of people just to be able to throw out some comments there. We don't have any questions yet, but we definitely got a couple of comments that are coming in. What is the next phase for rig automation? Where do you see it going in the coming years?
So what we've got is going to expand. So the automation is the only way to expand automation is drilling is a fixed set of processes. So we're not going to invent any more processes. Excuse me. But what we will expand is the number of apps or sub-processes, things that will then further refine processes. And so we're going to grow in that space tremendously. So the app space you will see, or the sub-process application phase is going to grow tremendously. Every year we try to bring out 4 or 5 new applications that then help these 5 processes that help us drill a well. So that is going to grow in this space. The next thing that's coming, and what's in test and is probably going to be in commercial really soon, is the robotics that we'll have on the rig floor. We will have manual arms on the rig floor now that will work in collaboration with the automation system for drilling, that will help you with tripping, that will help you with casing running, picking up and laying down drill pipe. So that's our next big automation foothold, if you like, in where we're taking our rigs. And we have a rig in test today. We'll probably be out in the next couple of quarters. We would have these systems installed. Once we get that going, the possibilities of performance and consistency are endless. In other words, it'll be another 2 years before we learn how many minutes or hours or days and time of tripping were lost without understanding or realizing the robotics that we would use for it. So robotics is the next big thing. So to summarize, David, applications is on the growth. Robotics is the next big thing for automation. And we will keep growing in this space, and we're going to keep building up our rigs to full content of automation rather than holding back and not investing the money in it.
Wow. Absolutely amazing stuff here. So let me ask you this. You had mentioned, having the feedback loop where you guys are getting, high frequency data. How much of a step forward will it be when we're able to get high frequency data from downhole to be able to feed the systems at surface?
Massive question, good question. Look, it has always been my dream, and having worked with high definition data downhole, it would be fantastic. But if you look at where we operate in US land and in Canada, these locations traditionally do not use a whole bunch of downhole data to bring to surface. However, that said, we are fully capable, or our systems are fully capable of bringing that data in, ingesting it into the architecture at the back. So, you name it, whether it's logging with resistivity, gamma ray, density neutron, etc. We have the capabilities today of bringing that data in real time and co-joining them with all our machine data to further understand what we're doing. So while I would really love to have that, and if any of the operators are listening on this call, I'd encourage you to push that data to Precision if you are using us. But the second thing I'd like to say is, if you are not using it, and if you have it and you believe that you can put it to use, and you think that you need help using it, we can help you. But to answer your question, US land and Canada are traditionally simple, more drilling oriented, less downhole data other than directional that comes to our systems.
Well, I had another question, but it shows not about me and my questions, right? So we got to go here. So Corey Schneider threw out a question. How does automation help with a customer's ESG initiatives?
Oh, great question.
Excellent question.
Great question. So look, I think, what causes our greenhouse gas emissions today at the rig site is your 4 generators, and if you're working in cold Canada, it's the boilers. And what we see is that typically we end up with somewhere around 20 to 25 tons of emissions in GHG per day. That's a lot of GHG per day for a rig. You use automation, you drill these wells faster, you drill them more consistently. In other words, you don't have, the more you trip, the more GHG, the more you pressure systems, or you don't clean the hole, the worse it gets for you to manage your GHGs. So when you start putting proper digital well plans in place, when you start to manage drilling effectively, you are now working towards reducing your GHG emissions. So we have measured this, that if we use our alpha systems today, there's somewhere between 20 to 25% of reduction in GHG in the space of actually drilling the wells quicker and drilling the wells more efficiently. If that answers your question, Corey. Thank you.
Corey, thank you for your question. All right, we'll get one more thrown in here. Jeff asks, are there projected estimates on how much time and cost this automation could save against not using the automation technology?
And this is my daily or our team's daily question that they get from the operators. It's a relatively simple question, and the answer is 20 to 25% better performance. But once you get to the 20 to 25%, you're going to ask me, hey, Ash, I'm already there. Now what? The now what is consistency. So you can get the 20 to 25% given your well or more, and then stay consistent from there on, where you keep that achievement that you made and not go backwards. In other words, you can drill a well in 20 days and you'll beat your AFE curves, but the next well you drill is in 24 days. And if you look at it over a project, you were sitting pretty much averaged out where you had planned to be. So automation will help you at an average of 20 to 25%. And we tell our customers the savings that we can bring about with automation are anywhere between $2,500 to, you can put a number to it, we say $4,000 per day in savings, if you like. So if you hire the automation system, that's what you're going to get in savings, somewhere between $2,500 to $4,000 of savings per day.
Wow, and that can be substantial numbers, given the size of some of the operations out there. Ashley, thank you so much for being here. I do want to give you one last chance here to give us your final summary and what's the best way to be able to get in touch with you and or the team there at Precision.
So the final piece that I'd like to give you is, I am very passionate about automation and the work that we're doing within Precision here to make automation, or to have made automation so successful. But the one thing I want to leave you, the drilling engineers, the young engineers, the operators, the one thing I want to leave you with is question what is automation. There is no unified terminology today in the industry. Everybody comes up and says, oh yeah, we have automation. Question what I mentioned about the 99.8% of sequences being completed, process sequences being completed. Question what these individual apps do and how they do it. Question what data you get back and how you use that data. You put all of these together, you become smarter. Automation helps you be consistent. And the only thing I'll tell you is try it out on a project and you will see the value that it brings you. With that, I'll leave it back to David, but to get a hold of me is relatively simple. You have my email on LinkedIn. I believe I even have my contact there. It's up on the screen now.
There we go. Connect with both of us.
Yeah, reach out to us. I have a really good team of people with me who can help you answer a variety of questions. We have people in my space, in my team, from operators, from data scientists, down to drilling engineers and rig operators, all commingled within one office area. So reach out.
Well, Ashley, thank you so much for being on the SPE Tech Talk show today. For everybody out there watching, please stay tuned. We've got more SPE Tech Talks coming up in the near future. And you can watch this replay on the SPE Energy Stream, the industry's digital pulse. More Tech Talks also coming soon on the Energy Stream, so go check it out, streaming.spe.org. All right. That's it from us today. Thank y'all also so much once again for being here. And until next time, Know your industry.
Thank you, David.
The energy industry is evolving rapidly. To stay informed, you need relevant content available when and where it's convenient for you. Introducing the SPE Energy Stream, the energy sector's platform for quality content from around the world. Energy Stream gives you access to technical solutions, innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event presentations, this easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders, then save the videos that interest you so you can watch them at your convenience. Stay ahead of the curve. Start watching SPE Energy Stream today.